Hello everybody and welcome to today's video. In today's video we are going to be talking about the law of cosines. This is most likely going to be your introduction into trigonometry regarding triangles that are not right triangles. So whenever we first start trigonometry, we talk about SOHCAHTOA and how those relationships apply to right angled triangles. So the law of cosines is going to be how trigonometry can relate to non-right triangles, any triangle in general. And the law of cosines is simply a squared plus b squared minus 2ab times the cosine of theta is equal to c squared. Now this law is a generalization of Pythagorean's theorem. Now we should all know Pythagorean's theorem as a squared plus b squared is equal to c squared, given that you're within a right triangle. So Pythagorean's theorem is a squared plus b squared is equal to c squared. Now let's go over and look at our law of cosines. Well, we have our a squared plus our b squared, and then we have all this mumbo jumbo. Well, what is theta? Theta is going to always be the angle opposite your missing side. So in this case, our angle opposite RC. What angle is opposite RC here? Well, it's a right angle. And cosine of 90 degrees is 0. So this full term would go to 0 and leave us with a squared plus b squared equals c squared. So the law of cosines still works for right triangles. With acute triangles, what do we have? We have some A, some B, and some C. Typically, we would know that a squared plus b squared, and for acute triangles, a squared plus b squared must be greater than c squared. And for obtuse triangles, we know that a squared plus b squared must be less than our c squared. However, with the law of cosines, we will be able to solve for the missing value, our other side, and we would also be able to solve for our missing angle if we have all three sides, given we can work backwards to solve for cosine of theta. So let's go forward and see how this can work. So here's an example problem. We want to solve for our variable x. So our first question is, how can we use the law of cosines? Again, the law of cosines, let's write it out for you guys. It is a squared plus b squared minus 2ab times the cosine of theta is equal to c squared. So how are we going to plug everything in? What is a, what is b, what is c, and what is theta? We have a lot of sides and angles to work with, and we want to make sure everything gets into the right spot. Well, the theta in question, the theta in the law of cosines, is always opposite the side in question. And in this case, our unknown side is x. Therefore, theta will be the 55 degrees. And our a and b are going to be 11 and 10. And we can pick which one's a and which one's b. That doesn't really matter. So whenever we plug in our values, we have 11 squared plus 10 squared minus 2 times 10 times 11 times cosine of 55 degrees is equal to x squared. Now we can, we'll simplify and just plug it into a calculator. So we have 121 plus 100. That's going to be 221 minus 2 times 10 is 20. Or rather, let's do 2 times 11 is 22 times 10 is 220. So minus 220 cosine of 55 degrees. And this is going to be equal to our x squared. And then we can just take the square root in order to find our x. So let's pull open a calculator and plug these values in and see what we get. We have 221 minus 220 times cosine of 55 degrees and it equals 94.8. And now we want to take the square root of this value and we get 9.7. So x is going to be 9.7. And then let's ask ourselves, does this answer make sense? Does 9.7 make sense? You always want to ask yourself, does my answer make sense? And in the context of this question, it does make sense because x is opposite 55 degrees, and 55 degrees is the smallest out of the three in this triangle. Therefore, x should be the smallest side length, and it is. So 9.7 does make sense as an answer here. Excellent. Let's continue onward. How would we solve this problem? This one's a bit simpler. We have less distractions. Again, let's remember our law of cosines is a squared plus b squared minus 2ab times the cosine of theta is equal to c squared. A and b are the sides that surround our angle theta. So we have 7 squared plus 6 squared minus 2 times 7 times 6 times the cosine of theta equals 9 squared. Now we just need to simplify. We have 49 plus 36 minus, we have 7 times 6 is 42. 42 times 2 is 84. So minus 84 times cosine of theta is equal to 9 squared, which is 81. Now let's simplify further. We have 49 plus 36, which is 85. We can subtract 85 from both sides and get negative 4 over here. And we have negative 84 cosine theta. Next, we can divide both sides by negative 84. And when we do that, we can simply have cosine theta is equal to positive 4 over 84. And then we can take the arc cosine of 4 over 84 to find the value of theta. Let's go ahead and do that in our calculator. Let's pull up our calculator. Clear it out. We have 4 divided by 84. That's this value. Now we're going to apply the inverse cosine and get 87.3 whenever we round. So theta is equal to 87.3 degrees. Excellent, excellent. So there is how we can solve for both side lengths and an angle. Let's step it up a little bit. Let's solve for a bunch of variables within a single triangle. So solve for the missing variables here. We have a missing side length and we have 2 missing angle lengths. So how are we going to do this? Which one should we solve for first? That's an important question. Which one should we solve for first? Well, in this case, I hope you're all thinking that we should solve for the x first. And we should solve for the x first because we have 2 of our side lengths and the angle that we do have is directly opposite the x. Therefore, we can just simply put it into our law of cosines and solve. Again, our law of cosines is a squared plus b squared minus 2ab times the cosine of theta equals c squared. And again, if you're wondering how the law of cosines is true, if you're wondering why it's true, I have another video on myself proving the law of cosines, so check out that video. So now let's plug in these values. We have 10 squared plus 13 squared minus 2 times 10 times 13 times the cosine of 52 degrees, and this will be equal to our x squared. So we have 100 plus 169, that's 269, minus 2 times 13 is 26, times 10 is 260, so minus 260 times the cosine of 52, and this is equal to x squared. And then of course we'll take the square root of this in order to have x. So let's pull up our calculator and plug this in. So we have 269 minus 260 times the cosine of 52. And we get 108.9. And then we need to take the square root of this value. Take the square root, and we get 10.4. So let's just round it to 10.4. So x, I'm going to replace it with 10.4. And now we can solve for either theta or phi. It doesn't really matter which of the angles we solve for first. So just because I like writing it more, I'm going to solve for theta first. So how are we going to solve for theta? Here, I'll switch to this purple color. So let's solve for theta using the law of cosines. So theta is directly opposite 13. So 13 will be our C, and 10 and 10.4 will be our A and B. Okay, so we have 10 squared plus 10.4 squared minus 2 times 10 times 10.4 times cosine of theta is equal to our c squared, which is 13 squared. All right, now we simplify. I do not know 10.4 squared off the top of my head, so let's go to our calculator. 10.4 squared is 108.16, plus 100 will be 208 plus 16. So this is 208.16 minus, and I also don't know what this is, so let's just go to the calculator. We have 2 times 10 times 10.4. That's 208. Okay. So minus 208 cosine of theta equals 169. Now we can subtract, or we can do subtract 208.16 from both sides. And when we do that, what do we get? We get 169 minus 208.16 is negative 39.16. And then we want to divide by negative 208. So we're going to divide by 208. And of course it's negative, so it will become positive. And so this is going to be a positive 0.188. So we have positive 0.188 equals cosine of theta. And so we want to now apply the arc cosine to this value. So let's multiply this by a negative. So now we have positive like we are supposed to. So let's apply the arc cosine and we can get 79 degrees. So let's just round to 79. So we know that theta is equal to 79 degrees. And if theta is equal to 79 degrees, what does phi equal? Well, we know that our triangle must sum to 100. Oops, I see that I'm blocking some of it. So we know that theta plus phi plus 52 will be 180. And if theta is 79, 79 plus 52 is 131. And then how many more does it take to get to 180? Well, 49 degrees. So 49 degrees is what phi is equal to. There we have it. That is how we can use the law of cosines to solve for values in a triangle that is not a right triangle. I hope you found this video helpful. Let me know down in the comments below, and I will see you in the next video.